Hi, my name is Alexandra Hoya. I'm from EC31 of DLSUD, and for this video, I'm going to do experiment 2 of my Digital Electronics 2 subject entitled Digital Input. For my Digital Electronics 2 subject, this is experiment 2. Title is Digital Input. So for the objectives, to learn how to create a project and build a project, to understand how the final code program to the microcontroller, to create a simple code for controlling an LED. Equipments and components used: a PIC 16F18875 IC, a 220 ohm resistor, LED, breadboard, connecting wires, picket tree, and power supply. So for the procedures of this experiment, here it is. First, you have to open MPLAB XIDE application. After opening the application, after the application is fully loaded, click File, Microchip Embedded, Standalone Project, and the device is the PIC 16F18875 IC, and click Next. This one, click that, Next, and name your project. Experiment 2. Finish. After that, a pop-up window should appear and you just save this configuration. Click Save. And here, next, what we need to do is go to Pin Module and click the grid view here of Pin Manager and change this to this one and select output at port 4A and input at port 4B. Next, we need to change this to that and that. After this, rename this LED, and this one is the switch. Next, here at the system module, select this one to high frequency oscillator 4 MHz, 4, and this one should be checked. Next is to generate. After waiting for a while, generation complete, and what we'll do is we'll head on here, source files, main C. After this, scroll down, and this is where we're going to place our code. So the code I'm doing here is a condition where if you turn on the switch or the switch has a value of 1, the LED would turn on, and if the switch has a value of 0, the LED would turn off. After finishing the file, click Build and build successful. After this, what we're going to do is transfer this to our IC. So to transfer our code to our IC, what we need to do is connect these accessories for the picket, which we need a picket tree, this IC-DC to this wire. So what we should do is connect this here like that, and you shall remember that this black wire here should be connected to the arrow here. And then connect this here, and this one should be connected to the computer, the other end of this wire. And then what we should do is connect the IC here
The U should be placed here. Make sure that this is up and connect it, and then we lock it. After that, we can now go on to the MPLAB XIPE app.
So here using the MPLAB XIPE, open it. We're going to transfer the hex file or the code to our IC. So let's just wait for the application to load. Once application is loaded, we can now connect the Picket 3. After this, a warning should appear and just click on OK. And this one, OK too. What we have to do here is change for the power settings. So in order to do that, on here and then you see a password microchip and then click on power. Make sure that this is at 3.125 and then we need to connect again. Browse for the hex file first. Change this to our project that we made earlier, exp2, and this default production in this hex file. And after that, we're going to program it. Hex file successfully loaded, programming, and programming complete.
After programming the IC or transferring the hex file to this IC, now we could place this to our breadboard and check if the code works. So for the first part of the experiment, this is the circuit that I built. So here you can see that this IC, the U port is here, and here the sixth pin is the RA4, or this is the LED. This green wire here connected dito sa resistor, tapos LED, and then this sa negative side ng LED, itong sa ground. And then this one, the 11th pin is the VDD. As you can see, connected siya sa positive terminal ng source. Itong VSS connected sa negative. And then here, this blue wire connected sa positive, VDD din to. And then this one is the VSS connected sa negative. And here, sa 37th pin, the switch RB4 is connected dito sa switch natin. And then yung isang side ng switch, this orange wire connected dito sa negative or sa ground rather. And yun, that's the circuit. Ito pala yung for the source, and this is the negative, positive, negative. So for the results for the first part of the experiment, when the switch is turned off, the LED is turned off, and when I turn this on, as you can observe, the LED lights up. So you can see here that the circuit works. Off, on, off, on.
For the second part, it is a condition that has a 2-second delay when the switch is on. So this is how we're going to edit the code from our previous code. We're just going to add delay here, 2000 millisecond for 2 seconds, and then this one we're going to change this to toggle. After that, we should build, and Once the build is successful, we will click that to rewrite the previous hex file.
After we edited the hex file or the code, what we need to do is just remove this IC and transfer it to the ICDC2 here, and we're going to transfer the code using the MPLAB XIPE.
So here is where we're going to transfer the code using the MPLAB XIPE. We're going to browse for the previous hex file just to make sure that was already edited, but we still do that to make sure. So yeah, programming complete. And now let's check for the results.
Once the IC programming is complete, we're going to bring this back to the U side again here. And if it's off, so here, as you can observe, if I turn it on, 2 seconds, on and off, 1, 2, 1, 2, 1, 2, 1, 2, and if I turn it off, it will not turn on and off for 2 seconds.
For part 3, 4 LEDs will turn on with 1 second delay when switch is 1. So to do this, we'll turn on output for ports port A1, A2, A3, and A4. Next, do the following. And then click generate. When generation is complete, we go to the main C file and edit our code. 1 second delay and the custom name that we gave earlier, and then we should copy this here for it to turn on when the switch is 0. All LEDs will turn on without delay, as you can observe from the code. After that, we can now rewrite the hex file and we're good to transfer the file.
Once we're done with the code for the 4 LEDs, again, let's transfer this IC to the ICDC. And connect our program.
Here, let's transfer the file to the IC. And programming complete.
Once programming is complete, we can remove it and place it back the U side here. Now, using this as our guide for our pin configuration, let's edit the circuit. now let's see if the circuit works. So I'm going to turn on the power supply, and as you can see, when it is off or the switch is 0, the LEDs do not turn off or on for 1 second. But if I turn this on, it switches on and off for 1 second.
For the last part, part 4, the own code and own circuit, what I made is when the switch is 1, I made it where it will have a delay, each LED will have a delay of 0.10 seconds, and when it is 0, two LEDs will have a delay of 1000, and the other two will have a delay of 2000. So here's the code. Build. After a while, build successful, and rewrite the hex file, and we can now transfer this to the IC using the MPLAB XIPE application. Click Program, Programming Complete.
So if you are to check for the output of the last code that I coded, we're to turn on the power supply, and if the switch is 0, these two LEDs are off, and this one will turn on in an interval of 1 second, and this one for 2 seconds, because this 2 is connected in RA1, RA2, and this 2 RA3, RA4. So yeah, and if I turn this on, or this is 1, if I turn that 1, you can observe that it has an interval or delay. This is for 1 second, this is 1.10, 1.2, and 1.3.
For the conclusion, using the applications MPLAB XIDE, MPLAB XIPE, and the equipments and components used in the experiment, it can be concluded that it is possible to program any input and output condition to the PIC 16F18875. Possible errors that one might encounter in the experiment are wrong pin configuration and connections, which may lead to improper interpretation of the program. For the recommendation, before conducting the experiment, one should have the knowledge in programming a code in the MPLAB application and transferring the code using the MPLAB IPE application. Also, it is essential to understand basic circuit construction.